Hypothesis testing. Statistical hypothesis. It is a statement about the numerical value of a population parameter. It is a statement or tentative assertion which aims to explain facts about certain phenomenon. Hypothesis testing is a procedure in statistics whereby analysts test an assumption regarding a population parameter. If the hypothesis is found to be true, it is accepted, and if it is found false, it is rejected. So therefore, the hypothesis, yung sinasabi nating hypothesis is pagbibigay ng explanation regarding dun sa mga evidences na nakuha natin. So, para mas maintindihan natin, we have two kinds of hypothesis. First is the null hypothesis, which is denoted by H sub O, and it is a statement that there is no difference between a parameter and a specific value. Pag sinabi nating null hypothesis, so it is equal siya, or it is equal to the parameter or the population. While the second kind of hypothesis is the alternative hypothesis, and it is denoted by H sub A. And it is the opposite or the negation of the null hypothesis. So kung yung null hypothesis ay equal siya sa ating parameter, then sa ating alternative hypothesis, hindi po siya equal sa ating parameter. So let me give you an example. So let's claim the average monthly income of Filipino families who belong to low income bracket is 8,000 peso. So for our null hypothesis, the average monthly income of Filipino families who belong to low income bracket is 8,000 peso. So therefore, the notation is mean is equal to 8,000. And for the alternative hypothesis, the average monthly income of Filipino families who belong to a low income bracket is not equal to 8,000. So therefore, the notation is mean is not equal to 8,000. So if you see the difference, so the null hypothesis is expressed through the use of equal symbol, while the alternative hypothesis is expressed by not equal symbol because the claim or the conjecture does not specify any direction. So let me give you another example. Let's claim the average number of hours that it takes a 10-year-old child to learn a certain task in a specific subject is less than 0.52 hours. So for the null hypothesis, so dapat equal siya. So therefore, mean is equal to 0.52. And for our alternative hypothesis, the average number of hours that it takes a 10-year-old child to learn a certain task in a specific subject is less than 0.52 hours. So therefore, the notation is mean is less than 0.52. So kung makikita natin sa ating problem, meron tayo dito, kung babasahin ulit natin dito, the average number of hours that it takes a 10-year-old child to learn a certain task in a specific subject is less than. Ayan. So, kaya yung ating alternative hypothesis is mean is less than 0.52. So, observe the alternative hypothesis is expressed with less than symbol because the claim or conjecture specify the use of the less than symbol. Now let's move to types of tests. So meron tayong types of tests. So first is the directional test and second is non-directional test. So ano ba yung difference nito? So directional test, so the rejection region is on one side of the distribution. It is either on the left or on the right tail of the curve depending on how the alternative hypothesis is tested. If the hypothesis contains the greater than symbol, then the rejection region is on the right tail of the curve. If the hypothesis contains the less than symbol, then the rejection region is on the left tail of the curve. The total area of the alpha which correspond to the rejection region is placed in one tail only. So, kung makikita natin dito, ayan. So, for directional test, sa ating figure dito sa baba, kapag greater than symbol ang meron tayo, then the rejection region is on the right tail of the curve. So, therefore, nandito yung ating rejection. So, mas madali na siya if makikita natin sa ating hypothesis is greater than. So, kapag less than symbol naman, then the rejection region is on the left tail of the curve. So, ito yung ating left tail. So, let me give you an example. So, let's claim the average weekly allowance of college student is less than 1,500. So, let's say the null hypothesis is the average weekly allowance of college student is equal to 1,500. Therefore, mean is equal to 1,500. And then the alternative hypothesis is the average weekly allowance of college students is less than 1,500. And the notation is mean less than 1,500. So, paano ba natin ito mapapakita sa ating bell curve? So, first, let's draw a bell curve. So, let's say this is our bell curve. And since we have the less than, so pag less than yung ating symbol, nasa left tail yung ating rejection. So, therefore, the rejection area is in this part. So, this is the rejection region. Then, eto namang part na to, ayan. Yung nasa right ng ating rejection area is the accepted region. So, mas maintindihan natin yan later. So, next is nondirectional. So, in nondirectional, in a two-tailed test, the rejection region is on both sides of the curve. If the alternative hypothesis contains inequality symbol, which is not equal, then the test of two-tailed, or the alpha, which correspond to the rejection region, is divided equally between two tails. So, paano ba siya? So, we have here the curve. So, kung nakikita nyo, dalawa yung shaded part niya. Since dalawa siya, dahil yung ating alternative hypothesis is contains of inequality symbol, so this is also a two-tailed. So, dalawang side yung ating rejection region. So, kapag nag-exceed dito yung ating test value, then it is rejected. Pero pag nandito naman yung ating test value, then it is accepted. So, let me give you an example. So, let's claim the average weekly allowance of college student is 1,500. So, the null hypothesis is mean is equal to 1,500 and the alternative hypothesis is mean is not equal to 1,500. So, kung ating siyang i-draw into our curve, so let's draw a bell curve. So, since the alternative hypothesis is contained of not equal, then the rejection area is on both side of the tail. So, yung rejection area natin andito, ayan. And then the accepted area ay nandito sa ating center between the two side of tail. Ayan. So, that is the difference of directional and non-directional kinds of test. Let me give you another example. So, the principal of the school claims that the mean age of the teacher is 45 years. the mean age of the randomly selected 35 teachers is 42 years, which is not equal to what is claimed by the principal. So here we are going to identify the null hypothesis and the alternative hypothesis. So first, let's recall what is the null hypothesis. So when we say null hypothesis, it is equal. And then kapag naman alternative hypothesis, it is not equal, which is denoted by not equal, greater than, or less than. So let's go back here. So the principal of the school claims that the mean age of the teacher is 45 years. So this is now our null hypothesis. So therefore, mean is equal to 45. And then, the mean age, so ayan. So the mean age of the randomly selected 35 teachers is 42 years, which is not equal. So pag sinabi nating not equal, ang symbol natin dyan is yung not equal. So therefore, the alternative hypothesis is mean is not equal to 45. So now let me give you another example. The mathematics teacher claims that the mean IQ of statistics students is 110. The mean IQ of the 32 randomly selected statistics students is 112, which is more than what is the mathematics teacher claims. So we are going to find the null and the alternative hypothesis. So let's go back to our problem. So the mathematics teacher claims that the mean IQ of the statistics student is 110. So this is our null hypothesis. So mean is equal to 110. And then for the alternative hypothesis, so kung makikita natin dito sa ating given, which is more than, so the symbol is greater than. So therefore, the alternative hypothesis is mean is greater than 110. So ganun lang po tayo mag-identify ng null and alternative hypothesis doon po sa ating given problem. Now let's proceed to the types of errors. So meron tayong two types of errors. First is type 1 error and the second is the type 2 error. So ano po ba yung difference dito? So type 1 error. So it is committed when the researcher rejects a null hypothesis when in fact it is true. So the probability of committing a type 1 error is also called the level of significance. For a 90% confidence level, the level of significance or the value of alpha is 0.1. This means that there is 10% probability that the researcher will reject a true null hypothesis. So for a 99% confidence level, there is a level of significance that is 0.01, and this means that there is 1% probability that the researcher will reject null hypothesis that is true. But if the researcher rejects a null hypothesis that it false, then he has a correct decision. So alpha is used to represent the probability of type 1 error. So meron tayong table dito sa baba. So we have the decision, the true state of name, the null hypothesis that is true, and the null hypothesis that is false. So, dito, sa decision natin, we have the reject the null hypothesis. So, if the researcher reject the null hypothesis, so eto, if it is true, then, eto na yung type 1 error. So, kasi nga, kung makikita natin dito sa definition niya, committed when the researcher reject a null hypothesis when the fact it is true. Kapag true siya. So, ni-reject niya kahit true. So, this is the type 1 error. Pero, kapag it is false, o yung researcher, ni-reject niya yung null hypothesis that is false, then, he has the correct decision. Ayan. Next natin is, the second type of error is type 2 error. So, it is committed when the researcher fails to reject null hypothesis that is false. But if the researcher fails to reject a true hypothesis, then there is no error committed. So, beta is used to represent the probability of type 2 error. So, we have here the table again. So, kanina, nireject niya yung true, then this is a type 1 error. Pag nireject niya yung false, then that is the correct decision. Dito naman is, kapag hindi na-reject ni researcher yung null hypothesis na false. So, eto na siya. Dito na tayo sa accepted the null hypothesis. So, kapag si researcher inaccept niya yung false, then this is the type 2 error. Pero, pag inaccept naman ni researcher yung null hypothesis na true, then that is correct decision. So, yun lang yung differences ng types of error natin. First is type 1 error, and the second one is the type 2 error. So, now we are here in accepting or rejecting the null hypothesis. We have the steps to follow kung i-accept natin or i-reject natin yung null hypothesis. So, first is determine the critical value using the appropriate statistical table. So, eto na yung pinag-aralan natin last time, yung t-distribution natin. Next is draw the rejection region of the critical value. And third is if the test value or the computed value falls to the rejection region, then reject the null hypothesis. Pero pag hindi naman napunta yung ating test value doon sa rejection region natin or reject region natin, then i-accept natin yung null hypothesis. So, para mas madali nating maintindihan, we have here the example. So, example 1. So, we have the hypothesis, the rejection region, and the decision. So, meron tayo ditong null hypothesis and the alternative hypothesis, which is equal to 50 and not equal to 50. And we have the test value ng 1.45. Ito yung ating gagamitin. And then, the critical value is positive and negative 1.96. So, sa ating alternative hypothesis, gumamit tayo ng not equal. So, therefore, sa dalawa yung ating rejection region. I-draw natin yung dalawang rejection region. So, kung makikita natin, so, ito yung ating rejection region. And this number is negative 1.96 and this is the positive 1.96. Dahil ito po yung critical value natin. The positive and negative 1.96. So ngayon, after natin ma-draw yung rejection region, magde-decide na tayo. So paano natin madidesisyonan? So titignan natin yung test value if magfo-fall siya sa ating critical or the rejection region. So 1.45 or positive 1.45, nasan po siya? Nandito, let's say nandito yung positive 1.45. So, since nandito yung positive 1.45 natin, wala siya dito sa ating rejection region. Ayan, wala siya sa rejection region. So, therefore, the decision is accepted. So, ganun lang tayo mag-decide. So, basta hindi siya magfo-false dito sa ating rejection region, yan, dito, sa two-tail natin, then it is accepted. So, the null hypothesis is accepted. So, let's have another example. So, example number 2. So, the hypothesis is, or the null is equal to 50, and the alternative is not equal to 50. So, the critical value is positive and negative 1.96. So, let's say both region yan. So, meron tayo ditong, ayan, sa two-tailed. So, this is a negative 1.96. Ayan. So, now, para makapag-decide tayo, itetest natin yung ating test value. So, to test our, the test value, so, yung test value natin is negative 2.15. So, nasan ba yung negative 2.15? So, this is negative 1.96. Then, nandito yung ating negative 2.15. Tama? So, if nandito yung ating negative 2.15, the test value, which is, this is the rejection region, then, therefore, the decision is rejected. So, the null hypothesis is reject. So, kasi nag-fall siya sa ating rejection region. So, therefore, the decision is reject. So, next nating example and last example is, example number 3. Yan. So, the hypothesis is, the null hypothesis is equal to 50 and the alternative hypothesis is less than 50 and the test value is negative 2.15 and the critical value is positive and negative 2.53. So, the rejection region is on the left dahil less than po tayo. So, di ba sa directional test natin is kapag ka left or less than, sa left region tayo or one tail. So, this is negative 2.53. So, we are going to test the test value if it is accepted or magpo-fall siya sa rejection region natin. So, this is the rejection region and the test value is negative 2.15. So, nasan ba yung negative 2.15? So, if yung negative 2.15, let's say nandito, ayan. So, hindi siya nag-fall sa ating rejection region. So, therefore, the decision is accepted. So, the null hypothesis is accepted.